Hello students. Uh, Today we'll discuss the last topic of module 2, that is MOSFETs, the construction and working of depletion type MOSFET and enhancement type MOSFET. So JFET we have studied. This is another classification of FET. MOSFET, metal oxide semiconductor field effect transistor. Okay, it is metal MOSFETs is insulated from the semiconductor channel by a very thin oxide layer. Where in the next slide we'll discuss the constructional diagram. There you can come across, you will come to know that the channel here in MOSFET is insulated or separated by a very thin layer of oxide layer. That is why it is the name oxide semiconductor field effect transistor. For this reason, MOSFETs are also called as insulated gate field effect transistor. As it is insulated, gate is insulated from the channel by a thin layer of oxide layer. It is also called as IGFETs, insulated gate field effect transistors. Like FET, MOSFET is also a three-terminal device where the drain current is controlled by the applied gate current. MOSFETs are further classified into depletion type MOSFETs and enhancement type MOSFETs. Okay. So first we'll discuss the depletion type MOSFETs here. In short, you can also sometimes find we call it as D MOSFETs. In some textbooks they do even refer as DE MOSFETs. Okay, so depletion MOSFETs, this is the symbol. This is the N channel D MOSFET symbol and this is the P channel D MOSFET symbol. Arrow mark is very important. So here you can make out there is a gap between the drain source terminal line and the gate terminal, which is to indicate that gate is isolated from the channel by a thin oxide layer. Whereas this, like this, you don't write in JFET. Only for MOSFETs, you can show as a separation between the channel and the gate here. So this is drain, this is source. For gate, there is a small separation which shows that here the gate is isolated from the channel. So for both the MOSFETs, this is how you write the symbol. Arrow mark is different for N channel depletion MOSFET and P channel depletion MOSFET. Okay. So types of depletion again. In JFET we have N channel JFET and P channel JFET, right? Same way here in depletion MOSFETs we have N channel depletion MOSFET and P channel depletion MOSFET. And look at the constructional diagram here. Metal oxide layer is extra here. That is where you have to be careful when you explain the MOSFETs. Okay. So a channel is physically constructed between drain, and here there is no channel between drain and source. A channel is physically constructed between drain and source here. Okay, depending on whether the channel material is N type or P type, it is called as N channel semiconductor material and P channel semiconductor material. So in case of N channel, there are two N plus regions linked by a channel. P type material is taken to form the base. Sometimes this is also indicated as the fourth terminal, that is substrate. P type substrate is there, right? From that a connection, ohmic contact is taken, and that can be called as substrate. Sometimes we call it as a body terminal. Okay, that is the fourth terminal of a MOSFET. Drain and source terminals are connected together through a metallic contact to N-doped regions. You can see this in the diagram. Gate is also connected to a metal contact but isolated from the channel by a very thin silicon dioxide layer. There is no direct connection between the gate and the channel in a depletion MOSFET. Because of the insulating layer SiO2 in the MOSFET construction, input impedance of the depletion MOSFET is very high. In fact, it is more than the JFET. Okay, so this is N channel. P channel, substrate is N, channel is P. That is why it is P channel depletion MOSFET. Okay, so what is an depletion MOSFET here? What we are discussing? N channel depletion MOSFET. That means the channel is there, N channel is there. So what happens? In the N channel, the majority carriers are what? Electrons. So what is VDS you are applying? Positive VDS. So electrons of the N channel are attracted by the positive VDD. So current starts flow through the MOSFET. So as you increase the value of VDS, what happens? Current ID starts increasing. Correct. So same thing is shown here in the other diagram. So next, look at the characteristics here. So current increases slowly, but at some point what happens? Again, because of the pinch off region, current becomes constant here. Then, but what happens when you make VGS negative? The negative potential at the gate will tend to repel electrons towards the positive p-type substrate and attract holes from the p-type substrate. But this results in recombination of holes and electrons, and there is a reduction in the number of free electrons. Therefore, the ID decreases with increase in negative gate source. So here negative gate source, the ID is reducing. The ID is reducing. So when you give VGS is equal to 0, some current flows through the MOSFET. But when you make VGS negative, what happens? ID reduces. So what happens if you apply positive value of VGS? The reverse operation happens and ID increases. I'll repeat. When you give VGS negative, what happens? There is a recombination of holes and electrons, and which causes the reduction in the number of free electrons in the n channel. So ID decreases. Positive value of VGS, the reverse operation and ID increases. So here depletion MOSFETs are said to operate both in depletion mode as well as enhancement mode. The current can be increased as well as current reduces. So VGS is equal to 0, ID is equal to IDSS. This is ID is equal to IDSS. When VGS is negative, current reduces. When you give VGS positive, current increases. So it operates in two modes, depletion mode as well as in enhancement mode. Okay. Similarly, you can also plot the transfer characteristics. You get either side for VGS positive as well as for VGS negative. This is depletion MOSFET. What is enhancement MOSFET is the same as depletion MOSFET, but there is no physical channel in case of enhancement MOSFET present. Channel we have to induce by giving proper gate voltage. Only then you get current through the enhancement MOSFETs. There is no physical channel in the enhancement MOSFET. Therefore, when you give VGS is 0, MOSFET is off. We don't get any current through the MOSFET. So it is also called as off MOSFETs when you give VGS is equal to 0. And the absence of channel we are going to indicate in the symbol by writing dotted lines here. We don't write a thick line as we write in case of enhancement depletion MOSFET. It is dotted line which indicates that there is an absence of physical channel in case of enhancement MOSFET. Again, here we have two types. One is N-channel enhancement MOSFET and P-channel enhancement MOSFET. Depends on what channel is enhanced by the application of a gate voltage. Okay, so now we'll take the N-channel enhancement MOSFET. What happens if you apply, when you give VGS is 0, current is 0. What happens when you apply VGS positive voltage and VDS positive? See here, the positive potential at the gate will pressure the holes in the P substrate, which results in a depletion region near the silicon dioxide layer. However, the electrons in the P substrate will be attracted towards the positive gate voltage, and what happens? They accumulate in the region near the silicon dioxide layer. Okay, and that concentration of electrons increases as you increase the value of VGS, which is nothing but ID increases. Okay, so the level of VGS that leads to significant flow of ID is referred to as threshold voltage, which will be marked in the characteristics here. Okay. So enhancement MOSFET, channel is enhanced, channel is induced. Okay, that is the main difference. Okay, so you can make out in the characteristics here, when VGS is 0, there is no current. As you make VGS positive, you get current through the enhancement MOSFET. So enhancement MOSFETs are said to be operated only in enhancement mode. There is no depletion mode here, as current increases as you apply more and more gate voltage here. Okay, similarly the transfer characteristics. This is the P-channel enhancement MOSFET characteristics. So MOSFET symbols, N-channel and P-channel MOSFET symbols. And one more question will be to differentiate between JFET and MOSFET, depletion MOSFET and enhancement MOSFET. So maybe now you will be able to list out some differences between JFET, MOSFET, depletion MOSFET and enhancement MOSFET, also the differences between BJT and FET. Okay, thank you.